So you do not participate in a professional learning community, and you think you know why you don't. You must have a roadblock that is getting in the way. You do not really know how PLCs can affect student achievement. Can collaborating with other teachers really make that much difference? Can participating in PLCs really make students more successful? The answers to your question are all the same. Yes, professional learning community participation, if based on the big ideas, can truly affect achievement in a positive way. The three big ideas of PLCs are: they are focused on learning, they create a collaborative culture, and they are focused on results. Let's look first at big idea number 1, focus on learning. Now let's take a look at PLC big idea number 2, collaborative culture. A PLC is made up of teachers who work interdependently to achieve common goals linked to the purpose of effective learning for all students. Collaboration is not effective if the team members are not focused on the right thing. And as we just discussed, the focus is on learning. Collaboration is important, but as Richard DeFore and others note, collaboration is a means to an end, not the end itself. Collaboration, just like formative assessment, is a process. Teachers work together to affect instruction and ultimately positively impact student achievement. Sometimes the PLC participants will engage in the problem-solving process as seen in the diagram. They identify the problem. What is the problem? They analyze it. Why is the problem occurring? They design instruction and their intervention. What are we going to do about it? And response to the instruction and interviewing. Is it intervention? Is it working? Big idea number 3 is focused on results. No matter the intentions, the results of the formative assessment process are what matter at this point. There must be evidence of student learning of the measurable academic goals. Using the evidence of student learning or of not learning, teachers identify and address areas of concern and determine which students need intervention. If the 3 big ideas are accomplished, PLC success is closer to affecting student achievement. Other things that need to happen in order for PLCs to impact achievement are for professional strengths to be indicated and replicated, and professional weaknesses noted and improved. Teachers dig deep into the data and adjust instructional practices accordingly. Specific data analysis strategies are used. A simple data analysis framework is to start by asking, across the grade level, were there specific objectives or tasks with which multiple students struggled? When discussing those students, be open-minded and acknowledge any preconceptions of each other as teachers. No matter what, however, effective PLC meetings have teachers leaving with additional questions as well as answers. Specific collaborative discussion techniques and protocols are used. There are many protocols and techniques. Teachers must make sure they define the language of PLC discussion. Using the words we, our, etc. make a difference. All conversations should be about the work, not the workers. One conversation protocol suggests to review data for 5 minutes. Use sticky notes to record 5 observations. Share those observations and place them into categories. Once observations are put into categories, open discussion takes place with everyone remaining objective. Conversation should be judgment-free. Let's take a look at one.
Next was fractions, multiplying fractions. And this is the beast right here. You can see how much more space it takes up in the table.
Why are meetings to analyze interim assessment data so important? They allow you to adapt your teaching to target what students didn't learn. Here, Jesse Rector is working with his math teacher, Paul Chin. At this point, Paul offers an analysis of why students didn't learn fractions effectively.
He said that the answer was 2 1/3, and I looked at it for a while. I was like, how could you possibly get that answer? And so then I realized what they did. They said that 7 times 7 was 14.
It's not?
So they were, they actually did step 1 correctly. They turned the mixed numbers into proper fractions, but then they did 7 times 7 was 14. And I think it was Ashley Glover who did it during the Do Now review, and she went, oh.
This initial analysis is helpful, but watch as Jesse pushes Paul to probe even deeper. Not only do they do the analysis, but they plan how to reteach this concept more effectively.
So, but the biggest thing that I wanted to mention is that it shows a lack of understanding in terms of value estimation. And I think it's a weakness that we need to just address in general. Like I've done a poor job of this every year I've been here, like just making sure that kids really think about, does my answer make sense? Like in terms of just maybe rounding it to the nearest whole number and saying, okay, so it's about 2 times 3, so it should be about 6. You know, instead of getting 2 1/3, they should realize, wait, 2 1/3 doesn't make sense.
All right, so let's flesh that out for a second then.
Sure,
What
sure.
are the, what's the process then for them to say that my answer can't be 2 1/3 because this answer's got to be closer to, at least 6?
Yeah, so the process, I mean, again, I think a lot of it is because I'm just not giving them the tools.
Right, so what are the questions
they
you
need
ask them?
Then you realize, okay, so if they want to do value estimation, we should basically just train them how to round. So just training them to say, like, so what's 2 1/3 approximately equal to as a whole number? That kind of thing, and they should say 2. What's 3 1/2 approximately equal to as a whole number? And maybe they round up to 4, that's fine. But just getting them to understand you can just round the mixed numbers or round the decimals first and then perform the operation.
Right,
Right.
so the steps are right, like what you want them to do is right, so what I want to think about is some
Yeah.
concrete action steps.
Sure,
so that
sure.
we can build that sort of level of like metacognition in them.
Yeah.
Jesse doesn't stop there. He continues to ask questions to get Paul to break it down into even tinier chunks of teaching to make sure that the reteaching is effective.
Yeah.
Or the modeling of this to look like so that students do this all the time.
Right. So I think what it starts with is we start with a worksheet that breaks down the steps of how you do it. So, step 1, round it to the nearest whole number. Step 2, perform the actual operation. And ask yourself at the end. I guess step 3 would be ask yourself, does your answer make sense?
So what does the worksheet look like?
So I think it looks something like that, and then so maybe it's like split down the middle, where on the left it's the value estimation, and on the right it's the actual work, that kind of thing.
Sure. So what I think what needs to happen, because it's a direct instruction model, is that you need to
Do the first one together.
no, not together. I
Or
actually think
I just show them.
right, the idea. And so in your lesson plan,
Sure.
you'll need to script out
what
exactly what you're going to say for the I do.
These few minutes are some of the highest leverage in an entire school day. Together, Jesse and Paul have planned a targeted lesson to address exactly what students need. When done repeatedly, these actions cause student learning to skyrocket.
So when? Is that
When is a great question. So I would like to do it immediately. I think I should just do
so
it
this
next
is week 1? Okay.
Yeah.
Great.
Collective wisdom of the PLC members always overrules individual thoughts or preferences. By working together, the members of a professional learning team are able to create something greater than themselves. Now you know how and why PLCs affect student achievement. Your roadblock is gone. Now go forth on your own PLC journey and know that success is ahead if you do.